So we are dealing with aldehydes, ketones, and carboxylic acids. Basically, those compounds which are having carbonyl groups. Carbonyl means C double bond O. Here you can see the carbon. If I'm talking that if the carbon is
Ma'am,
bonded
I
with
can't see your screen.
one. Is it okay now?
Yes, ma'am.
So what you're seeing is that C double bond to H. For this unit, CHO unit is bonded with hydrogen. If at all, I'm going to say one of this is also a methyl CH3 CHO. You can see I'm just increasing CH2 group here. So this order is called as homologous series. When you are having this HCHO or other than if there is no two R groups that are attached. Instead there is a R group and one H group. CHO unit is there. Then I call such compounds as aldehydes. So basically aldehydes are CHO units. When you're talking about ketones, same carbonyl only, but here it will be RCOR. If CHO is there, we call it as aldehydes. If CO along with two R groups is there, there is no hydrogen directly attached with the carbonyl, we call it as ketones. The next one is carboxylic acids. COOH. This could be anything. It could be R, aliphatic, or it could be aromatic as well. Here also you are able to see the carbonyl group is there. So only I mentioned all these three. The basic common thing among them is carbonyl groups. So we also call them as carbonyl compounds. So where is this carbonyl compounds much useful? In fabric synthesis, flavors, adding flavors. Aldehydes have characteristic flavors to them. In making plastics, in making drugs, drugs means medicines. In all these places, carbonyl compound is of much importance to us. In the previous unit, we have studied organic compounds with functional groups containing carbon-oxygen single bond. What do I mean by that? Now I'm having CH3OH, where the carbon and oxygen are bonded with a single bond. In this unit, we will study about the organic compound containing carbon-oxygen double bond. And this group is called as carbonyl group, which is one of the most important functional groups in organic chemistry. That is 100%. Most of the products that we are using is either synthesized using this carbonyl compound or the carbonyl compound itself is being used. In aldehydes, the carbonyl group is bonded to carbon and hydrogen. This is carbonyl where I'm having hydrogen here. While in ketone, it is bonded to two carbon groups. There is no hydrogen. The carbonyl compound in which the carbonyl group is bonded to oxygen are known as carboxylic acids. When the CO is bonded with oxygen, we call it as carboxylic acid. In the carboxylic acid, we are having derivatives here. Derivative means from carboxylic acid, what and all I can synthesize. I am having carboxylic acid to this. I am using thionyl chloride, where it will convert it into RCOCl. This is the halogen that they have denoted here. So what you are seeing right now is acid halide, or we generally also call it as acyl halide. Acyl means this group is called acyl group, RCO group. So since I generated from acid, I call it as acid halides, also called as acyl halides. Not just that, you can also have anhydrides of them. The word anhydride says you have removed water from it. Removal of water from carboxylic acid will form anhydrides. So these are the common derivatives of carboxylic acid. Not just that, you also have amides here, RCONH2. Where I have carboxylic acid, to this I'm adding ammonia, where I will have RCONH2. This is amide. CONH2 group is called as amides. And their derivatives esters. What is esters? Ma'am, I'm having carboxylic acid. I'm treating with alcohol, R-OH. Remove water. What will you have? RCOOR dash. This unit is called ester. Esters are usually fruit smelling. Very nice smell they give. Fruit smelling they are. So carboxylic acid derivatives like it could be ester, it could be aldehyde, it could be anhydride as well. So when this carbon is bonded with oxygen, I call it carboxylic acid. When carbon is bonded with oxygen, look at this, CO is bonded with oxygen. I call it as ester. Look at this, carbonyl is bonded with oxygen. I call it as, I club them as one group here, carbonyl compound in which carbonyl group is bonded with oxygen. It's known as carboxylic acid and their derivatives are also there, like esters, like anhydrides. While in compounds, where carbon is attached to nitrogen, like this, and to halogens, like this, are called as amides and acyl halides respectively. Okay. Aldehydes and ketones, carboxylic acid are widespread in plants and animal kingdom. Most of the things that is present in your body or which you use for flavoring, scents, etc., they have a role. They play an important role in biochemical processes of life. They add fragrance and flavor to nature. For example, vanillin. Look at the structure of vanillin, which is obtained from vanilla beans. Okay, the essence that you had, vanilla, that essence. Salicylaldehyde from meadowsweet and cinnamaldehyde from cinnamon. Then the common names, their sources, along with their structures is important for us. Let us look at the structure of vanillin here. I have benzene, to which I am having aldehyde. I have OH group as well. Okay, I have OH group as well. Similarly, look at salicylaldehyde. We will be learning why it is called salicylaldehyde and all. OH and CHO attached to benzene is called as salicylaldehyde. Cinnamaldehyde, where I am having C6H, CH double bond, CHCHO, cinnamaldehyde. As I repeated, told you, you should definitely remember the structures and the sources of these aldehydes. All these have very pleasant fragrance. Yes, of course, we have smelled it. They have very good fragrance they have. They are used in many food products, pharmas, to have claims. Some of these families are manufactured to use as solvent, that is as acetone. Some of these families are manufactured for use as solvents, that is acetone, for preparing materials like adhesives, that means glues type, paints, resins. Resins means those which are used in ion exchanges. They help to exchange ions, perfumes, plastics, and fabrics. In all these places, carbonyl compound have very good synthetic importance they are having. They are going for the nomenclature here. Aldehydes and ketones are simplest and most important carbonyl compounds. I am going with a common name here. Aldehydes and ketones are often called by their common names instead of IUPAC. This is very true. We generally don't call them by IUPAC. Instead, your NCERT question paper will provide only the common names of them. The common names of most aldehydes are derived from the common names of the corresponding carboxylic acid by replacing the ending ic of acid with aldehyde. Let me look at this. Initially, it should be CH3COOH. What is this called as? Acetic acid. Look at this. I'm just removing this ic here. I call this acetaldehyde. Can you see this? I'm just removing the stick and acid. Instead, I'm just adding the acetaldehyde. Look at the same one here. Benzoic acid. Remove this. Add aldehyde. Benzaldehyde. At the same time, the name reflects a Latin or Greek term for the original source of the acid or the aldehyde. The location of the substituent on the carbon chain is indicated by the Greek letters alpha, beta, gamma, delta, while the alpha carbon bearing the one directly linked to the aldehyde group. Let us look at this. This is the aldehydic unit. So the carbon that is very next to this aldehydic unit is alpha. Next is beta. Next is gamma. So at the beta position, I'm having bromine. So how do you name it bromo? Beta bromo. How many carbons are there totally? 1, 2, 3, 4. 4 carbons are there. So I call it butyraldehyde. Beta bromo butyraldehyde. Remember, we are talking about the common names, not the IUPAC names. If it was IUPAC, I would have always suffixed it with AL. Clear till this?
Yes, ma'am.
Common names of ketones are derived by naming two alkyl or aryl groups bonded to the carbonyl group here. The locations on the substituents are indicated by, as usual, alpha, alpha dash, beta, beta dash, and so on. Being the carbon atom next to the carbonyl group indicated as alpha, alpha dash. For example, I'm having CH3, CH2, CO, CH2, CH3 is there. To this, a bromine is there. To this, another bromine is there. For this carbonyl, the next one is alpha. Similarly here, this is next one alpha. So this is alpha, this is alpha dash, your wish. And I will say this is alpha, I will say this is alpha dash, your wish. Alpha, alpha dash, dibromo. Then I will call with the acetone name here, I mean ketone name here. Some ketones have historical common names. The simplest dimethyl ketone is acetone, very common one. What is the general purpose of acetone? It is a solvent. So this is acetone for us, CH3, COCH3. What is it? Simplest dimethyl ketone. Can there be any other ketone lower than this, smaller than this? Can we have any other ketone smaller than this? I'm asking a question here.
Um,
No, you cannot.
and
Ma'am, I'm having CH3CO. Instead of methyl, I put an H here, ma'am. This is no longer a ketone, it is an aldehyde. So the very first ketone that you will have is only acetone. Got
oh,
it?
yeah, okay, ma'am.
Next one is alkyl phenyl ketones. Alkyl is there, phenyl is there, ketonic unit is there. So generally they are being named by adding the acyl group as prefix to the phenone here. Look at this here. CH3CO is called as acetyl group, isn't it? And the benzene is being attached with a ketone group. So they called as acetophenone. Alkyl phenyl ketones are usually named by adding the acyl group as the prefix to the phenone, acetophenone. Look at the next one. Again, you can see it is phenone. Phenone. So whenever you are having a ketonic unit that is attached to benzene, you end it up as phenone. How many carbons are there? Three carbon. Propane, right? So we say propiophenone. You can see you're ending them as O. O. Propiophenone. Next one, look at this. And there are two benzene rings here. So let me assume this is phenone, then this is benzene. Benzophenone. Right?
Yes, ma'am.
Now we are moving for IUPAC name. As I mentioned, you should know vanillin, salicylaldehyde, and cinnamaldehyde for sure. The structure is a must for us. The IUPAC names of open chain aliphatic aldehydes and ketones are derived from the names of the corresponding alkanes by replacing the ending E with Al and on respectively. What do I mean by that? Look at this. How many carbon I'm having? Two carbon is there. So it is ethane. But there is an aldehyde here. So I remove this E. Instead I add Al to it, ethanol. Right?
Yes, ma'am.
In case of aldehyde, the longest carbon chain is numbered. Starting from the carbon of the aldehyde is very important. Because you can see when I'm having aldehyde, ma'am, this is aldehyde, ma'am. I'm having bromine also, ma'am. I'm having methyl also, ma'am. Your numbering will not start from any other carbon. Numbering should start from the aldehydic carbon itself. 1, 2, 3, 4, 5, 6, 7. 4 bromo, 3 methyl. How many carbon? 7 carbon F10L. Okay, da? Look at this here. It is a cyclic compound. Whenever you are having a cyclic compound, what should you do? Count the number of carbon in the cycle, count the number of carbon in the substitution. There are 5 carbons here, there is only 1 carbon here. So which is the parent molecule? This is the parent molecule. I regard this as a substituent here. There are two things. I am having CO group here, CH3 group here. Obviously, which should be given priority? This one. 1, 2, 3. 3 methyl cyclopentane it is, but it is a ketone. So I remove the E, I put one, pentanone. Understood? Let me take this CH3, COCH3. 1, 2, 3. 1, 2, 3. In any position I do, ketone gets the second position here, right? How many carbons? 3 carbon. So it is propan 2 one. At the second position, one ketone is there. In other words, I can say it is 2 propanone. Nothing wrong in it.
And what if, like, the chain has more molecules than the parent molecule? Then will the naming change?
Yeah. But here I am having ketone. In this case, there is no chance. In case I am just having this, let me say there are 7 carbons here. Then this will be the parent, this will be your substituent. I'll say it is 1 cyclopentyl heptane.
Mm-hmm. Ma'am, but because it's ketone, you always start from
Yes,
the ketone
yes,
only.
yes. It is just a mere substituent, but it is a functional group here. I should give the priority to this. So whenever your cyclic ring has major substituent, then that should be the parent here first. Whenever your cyclic ring is having more carbon, then that will be the parent again. And what if this is also having, here I am having, let me say here I am having COOH. Here I am having some functional group, chlorine is there. With respect to superiority, which is having more priority? Carboxylic acid. In that case, even though the cyclic ring is having less number of carbon, this will be my parent. Do you get it?
Yes, ma'am. Ma'am, so where's the order of cyclic ring like in the table? Like,
See, for
is it
example,
among the
if I'm having like this, is this your question?
ma'am with this also and also with like different ones like alcohol, ketones, and aldehydes and all of them.
No, I can't hear you properly. Can you please be a little bit clearer?
Uh, Ma'am, so like, wh- where is the cyclic ring in the table? Like, is it more important than alcohols and aldehydes, or like,
I'm just asking you to leave this, and I went for the first comparison. Now here I'm having this along with the cyclic ring here. So if your cyclic ring is having prior functional group, give its importance even if it is having less number of carbon. But in this case, this is having more number of carbon as well as it is having the functional group. So I give the priority to this.
oh, okay, ma'am.
I hope that was your question.
Yes, ma'am.
Okay. Yes. The substituents are prefixed in alphabetical order along with numerals indicating their position in the carbon chain. Remember, you should always go for the alphabetical order for sure. There is no doubt in it. The same applies to cyclic ketone. This is a cyclic ketone for us. Where the carbonyl atom is numbered 1. When the aldehyde group is attached to the ring, look at this. Now here I am having a aldehyde group. Then what will I do? The suffix carbaldehyde is added after the full name of cycloalkane. Cyclohexane carbaldehyde. Okay. The numbering of the ring carbon atom starts from the carbon atom attached to the aldehyde group. Very important. Ma'am, from where will I start it, ma'am? From here. First position, aldehyde is available. So the cyclohexane 1 carbaldehyde, they are just removing this 1 here, which is understandable. The name of the simplest aromatic aldehyde carrying the aldehyde group on a benzene ring is benzene carbaldehyde. This one. You know the common name. What is the common name? Benzaldehyde. What is the IUPAC name? Benzene carbaldehyde. However, the common name benzaldehyde is also accepted by IUPAC. So you can see people generally don't address it as benzene carbaldehyde anymore. We call it as benzaldehyde itself. The other aromatic or ends named as substituent benzaldehydes. I'm having chlorine here. How do I name this? 1 and 2. 2-chlorobenzaldehyde. Understood, right?
Yes, ma'am.
Look at it. 1, 2, 3, 4, 5. The second carbon, I'm having the ene. Totally how many carbon? 5 carbons. So pent. The second position it is ene and it is an aldehyde. Pent to ene al. So if the questioner is asking you, giving you the name, asking you to build the molecule, if this name is provided, there is a pent, 5 carbon. At the second position, there is double bond and it is an aldehyde. So I understand 1, 2, 3, 4. This should be an aldehyde group. 1, 2. Second position is an ene. So the double bond should be present here. Understood?
Yes, ma'am.
Let's go for the next molecule. Am I having benzene? I'm having 3 carbon system. How do I name it? I should give the priority to my carbonyl groups for sure. So I do 1, 2, 3. At the first position, phenyl is attached. Ma'am, isn't benzene a larger carbon number compared to this carbon number? So shouldn't I end it with benzene here? No. I have benzene with carbonyl and an ethyl group is there. That's what is given. CH2, CH3, ethyl group is there. So this is my major functional group here. I regard both of them as my substituent only, right? But among them, I tend to prefer to call it as propane 1-O because it is three carbon system. With the carbon at the first position, at the same carbon, benzene is also substituted. Whenever benzene is another substituent present here, then I call that benzene as phenyl. One phenyl propane 1-O. Okay, pa?
Yes, sir.
Let's go for it. When I'm having ketone is also there, aldehyde is also there. The preference is for aldehyde over ketone. 1, 2, 3, 4, and 5. Whenever ketone and aldehyde both are present in the same compound, I call the ketone as oxo. Aldehyde is also there, ketone is also there in the same compound. Then I call the ketone as oxo. 3-oxo. Totally 5 carbon pentanal. You can see we are ending the name with al. So aldehyde is the priority here for us. Okay. 1, 2, 3, 4, 5. Either ways. 1, 2, 3, 4, 5. So we can see in either way at the second position and the fourth position. 2 methyls are there. So 2, 4 dimethyl, 5 carbon system it is. Pentan. Third carbon ketone is 3-O. Let's go for the next compound. 4-nitro benzene carbaldehyde. This is also accepted. Or benzaldehyde is also accepted. Which is primary? This is primary. 2, 3, and 4. 4-nitro benzaldehyde. Let's look at this compound here. Whenever you are having more than one time, if the same functional group is present more than once, I'm having 2 times. In that case, 3 times you're having here. Choose your parent molecule. Leave out the numbering here. In all the places you mentioned 1 for aldehyde. Correct, Ada? Look at this. In all the places, we said 1, 2, 3, 4. I included aldehyde as 1. But this is the first time you are seeing we are not including aldehyde as 1. When will I do this? When not just aldehyde, any molecule it is. When the same functional group is repeating it for more than once, then I will not take their name. Look at what's happening. I'm taking this propane 3 carbon 1, 2, 3 propane 1, 2, 3 tricarbaldehyde. It is carbaldehyde, right? So I call it tricarbaldehyde.
Ma'am, so does that mean if there's like a fourth CHO, it'll become 1, 2, 3, 4
Ah, yeah, correct.
tetracarbaldehyde?
Mm,
Okay.
yes.
Okay.
Let's go for the common namings here. Let's do the common name, then you will go for IUPAC. Formaldehyde. HCHO. This group is called as formal group. Formaldehyde. Next, acetaldehyde. I am adding an acetyl group here. CH3COH. Acetaldehyde. Next one. Isobutyraldehyde. Look at this here. CH3 twice. CHCHO. So I am having CHO. To this CH is there. To this two CH3 molecules are attached. You can see it is looking like an isobutane group, correct? What is isobutane? This is isobutyl group, correct, Papa?
Mm-hmm. Yes, ma'am.
This one is called isopropyl group. This is called as isobutyl group. So looking at this group, I understand it's just looking like an isobutyl group here. CCCCHO. Isobutane only, but there an aldehyde is there. So I call it isobutyraldehyde. Let's go for the next one. One, two, three. Number if I give, it goes for IUPAC. Instead I give alpha, beta, gamma, it goes for common name. Alpha, beta, gamma. Correct? No? But ma'am, there was no two aldehydes. What are they? There is a methyl and an aldehyde. So what will be given important? Aldehyde only. Alpha, beta, gamma. This carbon is gamma. What is present at gamma carbon? Methyl. Gamma methyl. It is cyclohexane formaldehyde. Clear? Ra?
Yes, ma'am.
Let's go for the next one. CH3, CH. To this, the OACH3 is there. There is a CHO. Which is important? Obviously, aldehyde is important. To this aldehyde, which is alpha carbon, this is alpha carbon. What is present in alpha carbon? Methoxy group. OCH3 group. It's called methoxy. It's a ether. Alpha methoxy. Are you having three carbon system? Yes, I'm having. So I have propionaldehyde. Aldehyde.
Yes, ma'am.
So the next one. Valeraldehyde. We are looking at the common name here, which is valeraldehyde. 5 carbon containing aldehyde is called as valeraldehyde. Next, acrolein. What is acrolein? Vinyl aldehyde. It's called as acrolein. You can see this. CH2, double bond CH2. Instead of one hydrogen, a CHO is there. Vinyl aldehyde. This is acrolein. Next, taldehyde. Basically, this acid is called as phthalic acid. We just now learned. Usually, with respect to the acid, I just remove the zinc and acid. I just add aldehyde name to that. That's what you're seeing. Taldehyde. Next one. Alpha,
Ma'am, can you
B.
repeat the explanation for that again?
we discussed whenever want to name this aldehyde, consider this example we saw. We derived this name from benzoic acid. I removed oic and acid. Instead, I just added aldehyde to it. Same thing you are doing here. The acid is called as phthalic acid. You remove ic and acid, just make it as aldehyde.
Okay.
Okay. Next, alpha, beta, gamma. Correct? Okay, ma'am.
Yes, ma'am.
But this alpha, beta, and gamma you will use for aliphatic compounds. What kind of a compound is this? Aromatic, isn't it? It's a benzene. So I won't use alpha, beta, gamma. Instead, I'll say ortho, meta, and para. Sorry, ortho, meta, and para. To the substituent that is very immediately present is called as ortho. This is ortho, this is also ortho. The next one is meta. So the meta position what you're having? Bromine. Meta bromo benzaldehyde. Let's go to the next molecule, ketone. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Which way should I use? Definitely this way. Why? I am able to give the lowest number to the carbonyl. 2. Correct, Appa?
Yes,
Hello?
ma'am.
Yeah. But this is not IUPAC. What you are discussing is common name. Now how do I discuss it now? CH3, CO, CH2, CH2, CH3. The smallest one looks like a substituent for me, methyl. It is an straight string, N. N means straight. How much carbon are there? Along with this ketonic unit, 3 carbon is there. Propyl ketone.
Ma'am, but why are they naming it like this? Isn't just like a normal ketone? Isn't it two, three, four, pentanone?
Here we are discussing about common name. IUPAC name is pentanone. We are discussing about common way of
Oh,
addressing it. Look at the next one. You have to know both common name and IUPAC name which is provided in NCERT. They'll just mention methyl N propyl ketone. What is its IUPAC name? So you should know what is methyl N propyl ketone. Next one, isopropyl ketone. What is isopropyl? This is isopropyl unit. I say it is diisopropyl. So both the places isopropyl are there and in center I have ketone. That's what they said. Diisopropyl ketone. CH3 twice CH. CH3 twice. In between I have CO. Okay. Next one.
yes, ma'am.
Now it is a cyclohexanone. To this carbonyl. Which is alpha? This is alpha. To this carbonyl, which is alpha? This is alpha. At the alpha, what do you have? Methyl. Alpha methyl cyclohexanone. The next one is methyl oxide. Very important one. You should short know the structure of methyl oxide. This is methyl oxide. CH3 twice, C, double bond CH, CO, CH3. So you can see it is encyclic ketone. Okay, acetyl oxide. Let's go for IUPAC now. In common name, you say aldehyde, you say ketone. In IUPAC, I say AL, I say ONE. How many carbon? One carbon. So it's a methane family. Remove E, add Al, methanol. How many carbon? Two carbon, ethane family. Remove E, add Al, ethanol. Go for this. One, two, three. 2-methyl propanol. Picture understood?
Yes, ma'am.
Okay. As I told you, IUPAC will consist of numbers. No Latin or Greek symbols here. This is 1. The carbon that is bearing CHO is 1. 2, 3. What is present at third? Methyl. 3-methyl. Cyclohexane carbaldehyde. We have seen this utilization of carbaldehyde whenever the cyclic ring is attached with aldehyde. Okay, next one. CH3, CHO, CH3, CHO. 1, 2, 3. At the second carbon, what do you have? Methoxy. 2-methoxy. Totally how many carbon? 3 carbon. It's an aldehyde, propanol. Next. Now it's a straight chain. 5 carbon containing aldehyde. 1, 2, 3, 4, 5. It's a pentane, but it's an aldehyde. So remove E, add Al, pentanol. Next one. 1, 2, 3. Aldehyde or ketone will be given preference than double bonds. Triple bonds as well. So it's a 3 carbon system. Yes. Pro. I'm having at the second position I'm having a double bond. So 2 ene and it is an aldehyde. Al. Prop to enal. If the name is given, how do you construct it? It's a probe, 3 carbon. It contains aldehyde. 1, 2. The second carbon there is ene. So put a double bond. Okay. Next one. It is benzene. At first and second position there is aldehyde. So we know when this aldehyde is present to the cyclic ring, either you call it as benzaldehyde or you call it as carbaldehyde. Both are acceptable. But ma'am, 2 aldehydes are there. I repeat, 2 aldehydes are there. If the same functional group is repeating more than once, what do? You take the parent, benzene, at the first and second position. I am having 2 carbaldehydes, dicarbaldehyde. Okay, next one. I'm only one aldehyde, so definitely you can use benzaldehyde term itself, nothing wrong. It's not necessary you should use carbaldehyde, benzaldehyde is also fine. 1, 2, 3. 3 bromo benzaldehyde. 1, 2, 3, 4, 5. It's a pentane. The second position I have one. Pentan 2 one. Next one. 1, 2, 3, 4, 5. At the second position there is a methyl. At the fourth position there is a methyl. 2, 4 dimethyl. Totally how many carbon? 5 carbon. Pentan. Third carbon I have one. Pentan 3 one. Next one. 1, 2. The second carbon I have methyl. 2 methyl cyclohexanone. Next compound acetyl oxide. 1, 2, 3, 4, 5. Fourth carbon there is a methyl. Totally 5 carbons are there. So I say 4 methyl. Pent. Third carbon there is a double bond in. Second carbon it is a ketone 2 one. Okay, done?
Yes, ma'am.
So with that we completed the IUPAC nomenclature of the aldehydes and ketones. If you know what is provided in NCERT, it's more than enough. 100% enough for attending your boards. We are going to the structure of the carbonyl group. How does it look like? So ma'am, let me say HC double bond OH it is. How many sigma bonds the carbon has made? 3 sigma bonds. So always we take for hybridization only the sigma bonds. So I need 3 sigma bonds is made. That means I need 3 hybrid orbitals. If I need 3 hybrid orbitals, then it should be sp2 hybridization. Because 1 plus 2 is 3. So the carbonyl atom is sp2 hybridized and forms 3 sigma bonds. The fourth valence electron of carbon remains in its p orbital and forms a pi bond, this one. Because carbon comes with 4 electrons. If 3 is forming a sigma bond, the fourth should be the one which is involved in the pi bond formation with oxygen by the overlap with p orbitals of an oxygen. In addition, oxygen is also having 2 non-bonding electrons, of course. Oxygen came with 6 electrons, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. It went on. So I'm having two non-bonding electron pairs. Thus the carbonyl atom and the 3 atoms attached to it lie in the same plane. And why? When I say sp2 hybridization, what is the geometry? Trigonal planar. The word planar says that all of them are lying in the same plane. Which are lying in the same plane? The 3 atoms that is attached to it are lying in the same plane here. What do I mean by the 3 atoms? Look at this 1, 2, and 3. All the 3 are in same plane. And the pi electron cloud is above and below this plane, of course. And I said HCH double bond O. If this is a pi cloud, the cloud could be seen above as well as below the plane. This bond angle is 120 degree as expected as of trigonal coplanar structure. What is coplanar? That means all of them are lying on the same plane together. That is called coplanarity. So the bond angle for trigonal planar is 120 degree. They are at 120 degree to each other here. The carbon oxygen double bond. If I'm pushing the electron like this, you can see the carbon carries positive, oxygen gets negative. Because of the electronegativity difference that they have. The carbon oxygen double bond is polarized. No one is polarizing it. Already it is a polarized molecule only due to higher electronegativity of oxygen relative to carbon here. Hence, the carbonyl carbon is electrophilic. It is a Lewis acid. Why? Because it carries a positive charge. What is a Lewis acid? Anything which is deficit of electron is called as Lewis acid. The carbonyl oxygen is a nucleophile. It is a Lewis base. Why? Because it's having negative charge. It can attract another electrophile with this electron pair. Carbonyl compounds have substantial dipole moments. What do you mean by dipole moment? Polarity difference. Polar difference is there. You can see this is positive, this is negative. And are polar than ethers, very important. And I'm having RCOR. I'm having ROR now. Here this is substantially positive, this is negative. So they are having very good polarity compared to ethers. The high polarity of the carbonyl group is explained on the base of resonance, involving a neutral A and a dipolar B. What is neutral A? Look at this here. This molecule is neutral here. It doesn't. It has got nothing here. Correct, huh? But here it is dipolar. What is dipolar? Two charges it is having. Because of this resonance possibility, there is high polarity in the carbonyl group. Clear?
Yes, ma'am.
Yes. Let's start doing 12.1. Alpha methoxypropienaldehyde. So I can understand there are three carbons here. The third carbon or the first carbon for you, either way you say, should have an aldehyde. This carbon is alpha to it. Here what it is having? Methoxy group. Alpha methoxypropienaldehyde. Okay,
Yes, ma'am.
next one. 3-hydroxybutanol, 4 carbon, and it should be having aldehyde as well. 4 carbon, 1, 2, 3, 4. At the third position, there is OH group. Okay,
Yes, ma'am.
yes. 2-hydroxycyclopentane carbaldehyde. So it's a cyclopentane. An aldehyde is there. So only I call it as carbaldehyde. So this is 1, this is 2. At the position I am having hydroxy. 2-hydroxy cyclopentane carbaldehyde. 4
Ma'am, what would
oxopentane.
and I have a doubt, like if the aldehyde was directly connected to the cyclopentane, what would it be named?
Cyclopentane carbaldehyde. That is its
No, like
IUPAC name,
right
right?
now it's yeah, but now it's CHO, right? So what if it was like directly connected to the carbon of the cyclopentane? Would the
Then it is
name be
called
different?
It will be cyclohexanone, pentanone.
Even if, oh,
This
okay.
is
Okay,
pentanone,
sir.
right? You can see
Okay, ma'am.
two R groups are there, so it's a ketone.
Oh, so we can't make an aldehyde like this.
No, you can't make it.
Okay,
You can see
okay, ma'am.
always aldehyde is in the terminal sites. Ketone is always internal. I see.
Yeah, okay, ma'am.
You can never say this aldehyde is in between a carbon chain. Not possible. It will be protruding outside. But ketone is not like that. It will be in between the carbon chain only, like this. Understood?
Okay, ma'am. Got it.
Yeah. 4-oxopentanol. I can understand aldehyde is also there. Ketone is also there. One, two, three, four, five. It's a pentane containing aldehyde. Correct? Pentane containing aldehyde. One, two, three, four. Here ketone group is there. 4-oxopentanol. Next. Disecondary butyl ketone. So it's a ketone. It's not a IUPAC name. They are given a common name here. You can see most of the places they're asking common names as well. Disecondary butyl. So it's a secondary butyl. Two times it is available. What do you mean by secondary butyl? It is a butyl actually. One, two, three, four. At the secondary carbon of this, the bonding has happened. A carbonyl is here. This is a ketone. One, two, three, four. One, two, three. So it's a butane. Two times the butane is repeated. But at which position the bonding has happened? At the secondary position. You get it? You could have done the bonding here as well. Both are same for us. Here also I could have done the bonding, isn't it?
Yes,
Is it a
ma'am.
secondary carbon here?
Yeah, it's still a secondary carbon.
Yeah. Next. 4-fluoroacetophenone. Draw the structure of acetophenone. Benzene, COCH3. This is acetophenone. It's an acetyl group. Benzene attached with ketone will be called as phenone. Acetophenone. And they are saying 4-fluoro. That means this is 1, 2, 3, 4. This is 4. Here fluorine is there.